Hey friends, and welcome. And in this video we'll be looking at the 2017 science paper 1. This was a GCE paper, so this is the ECZ GCE paper 2017 science paper 1. So this is physics. So science paper 1 is physics and science paper 2 is chemistry. So for this video we'll look at the science paper 1 physics paper, and we'll look at section A only, so we can get into answering some questions. So section A is multiple choice, and you're given 4 options, A, B, C, and D, and you have to pick your best option, the best option. So let's get into question number 1. So question A1 says, the diagram below shows part of a ruler used to find the length of a nail. So we've got a nail and we've got a ruler there, and our ruler starts, and our nail has been placed from point 1 to that point, and it is in centimeters. So the question is saying, what is the length of the nail? So it's from 1 to 2 to 3 to somewhere there. So it's the nail hasn't been placed on point 0, and so we would say, we'll take this as our point 0, so meaning it's 1, 2, point 1, 2, 3, 4, 5, 6, 7. So we've got 1, 2.7, so it's 2.7. So we can see that our nail is ending somewhere there. So this is 2 centimeters and 0.7 centimeters, which simply gives us 2.7 centimeters as our nail length. So meaning the correct answer for question number A, or for question A1, is B. So we can't say 3.7 because it's starting from 1, it's not starting from 0. If the nail was placed at point 0, then we would say 3.7. But since it was placed at 1, we would say 1, 2.7. Okay, move on to question A2. The diagram below shows a block of wood of density 0.6 grams per cubic centimeter. And we've got the dimensions of the block of wood. We've got 5 centimeters, we've got 1 centimeter, and we've got 10 centimeters. What is the mass of the block? So what do we have? We have the density. We also have the dimensions, which would give us volume. And how would you get mass given density and volume? We know that density is equal to mass over volume, right? So to get the mass, we'd simply say mass equals density multiplied by volume. But do we have the volume? No, we have separate dimensions. So how do we get the volume given those dimensions that we have there? So to get the volume, we know that volume is in cubic centimeters. So to get the volume, we would simply have to multiply the length, the width, and the height. So we'd have to say, to get the volume equals, we've got 5 multiplied by, we've got 1, and we've got 10. So this gives us 50 centimeters cubed, right? And to get the mass, we've said it's density multiplied by volume. So mass equals density, which we've been given as 0.6 multiplied by the volume, which we have found to be 50, right? And you can use your calculator. You can also say 0.6 in fraction form is 6 over 10 multiplied by our density, which is 50. And so that's 0 and that's 0 go. And we would have 5 multiplied by 6, which gives us 30. And what are the units for mass? Mass is given in grams. So we'd have 30 grams. Do we have 30 grams on our options? And yes, we do. So the correct answer for A2 is A, which is 30 grams. Question A3 says, The diagram below shows a graph of how a distance covered by a woman varies with time as she takes a walk from her home to the market. So we've got a distance time graph, and we've got point A, we've got point B, we've got point C. So the graph is steep between 0 and A, and then it is straight, it is horizontal between A and B, and it is steep between B and C. And the question says, what was happening in the region AB during the woman's walk? So between 0 and A, we can see that distance, which is in the y-axis, is increasing. So meaning she is covering a certain amount of distance between 0 and A. But then between A and B, the distance is not increasing. The distance that she's covering is not increasing, it's just constant. And then between B and C, we can see that she's covering another distance, a different distance between B and C. So with reference to the time, which is in the x-axis, we would find that between times 0 and A, the time between point 0 and A, she covered a certain distance. And then between time interval A and B, so B is there, the distance that she covered, she didn't cover any distance, it was constant, meaning she wasn't really moving. But then between the time interval B and C, she had covered a distance, meaning the distance graph, or the distance part of the graph, had increased. So this is telling us to say she moved between 0 and A, she did not move between A and B, and she moved between B and C. So this is therefore implying that our correct answer, looking at the options that we have, is D, which is stopped walking. If she was walking, she would have been covering a distance. But since it is horizontal between points A and B, it simply means that she was not walking and no distance was covered. And so the correct answer is D. We can move on to question A4. A4 says, a parachutist of mass 60 kg falls with a constant velocity of 5 meters per second, together with a parachute of mass 20 kilograms. So this man has 60 grams as his mass or her mass, and then this person has a parachute that is weighing 20 kilograms. So altogether we have total mass, so let's say mass, put a T to symbolize total. Total mass is equal to the mass of the person, which is 60, plus the mass of the parachute, which is 20, and this gives us 80 kilograms. Okay, what else have we been given? We've also been given the velocity, so V equals 5 meters per second. Then, and it's constant, okay? And then taking G to be 10 Newton per kilogram, what is the resultant force on the system? What is the resultant force on the system? So, as you prepare for a final examination, you need to know that force is simply equal to mass multiplied by acceleration. Mass times acceleration. Are we together? So what mass do we have? We have mass being equal to 80, right? And we've been told to say a parachutist of mass falls with a constant velocity of 5 meters per second, taking G to be 10. So now, what do we take as our acceleration? So in this question, we've been given two statements, which might be seen as contradictory because we have constant velocity, 5 meters per second, and we also have G, which is force, the gravitational acceleration being equal to 10 Newton per kilogram. So what do we take as our acceleration? So whenever something is falling, free fall, we say the acceleration that it's falling with is always due to gravity, which is 10 Newton per kilogram, so we'd have our 10 there. So therefore the force that this person is falling with would be 80 multiplied by 10, which gives us 800 newtons. 800 Newton, and 800 Newton is option D, 800 Newton. And so we can move on to question number A4. A4 says, diagram shows a frictionless pulley used to lift an 8,000 block of concrete. So we've got a block of concrete which is weighing 8,000 newtons, and we've got a pulley, and this pulley, this system of pulley has 1, 2, 3, 4 pulleys. So the question goes on to say, what is the minimum effort required to raise the block? So we've got our load of 8,000 newtons, right? But then we've got how many pulleys? We've got 1, 2, 3, 4. So because of this, this is a simple machine which is helping to reduce on the amount of energy that you will have to use to lift this block of concrete. So these pulleys are helping you by reducing the amount of work that you have to do and the amount of energy that will be needed. So we've got 4 pulleys, and how does that relate to the effort that will be required to raise this block? So since there are 4 pulleys, it simply means each of them is doing some work to reduce on this 8,000 newtons. So we've got 4, and so we'll divide this 8,000 by 4. So if we had 5, we would have divided by 5. If we had 3, we would have divided by 3. But since we've got 4, we'll divide by 4, and this will give us 8,000 divided by 4 will give us 2,000 newtons. So let's just check our answers to see if we have a 2,000 newtons anywhere there. And we do have a 2,000 newtons at B. So our correct option is option B, 2,000 newtons. Question A6 says, the diagram below shows a model of a crane with a counterbalance weighing 200 newtons. This counterbalance can be moved further or closer to 0 to accommodate different loads. So we've got this crane, but we noticed that there was an error on this question, because according to the question, they said a counterbalance weighing 200 newtons. But when you look at the diagram, our counterbalance was 800 newtons. It was weighing 800 newtons, and it was there. So here's, so I'll just run through how you can tackle such a question, but I will not give you a definite answer to this question because there was an error, and so we would have 2 different answers depending on what they were trying to ask. Yeah, depending on which information you use, whether you use the information in the question itself or you use the information in the diagram, provided in the diagram that was given. So this is simply relating to the principle of moments. So when you have a pivot there, you've got this simple system. You've got a pivot there, and you've got the load at this point. And you've got another load, let's say, at this point, right? And this distance is, let's say, 3. Maybe let's just go with the same figures given. We'll go with the figures given in the diagram. So we have 2 there, and we have 1. These are in meters, and then this load on this side is the counterbalance. Here will be seen as 800 newtons. And then they're asking us to say what is the maximum load the crane can lift safely. So we are asked to find this load on this side that this crane can lift safely. So this crane can be moved further to accommodate different loads. So to find the maximum, we'd simply have to find the maximum moment that this counterweight can offer, or the moment that this counter crane, the maximum amount of moment that this counter crane, that this counterweight can offer. So we've got 800, so we know that moment is equal to mass, or rather, sorry, moment is simply equal to the load or weight multiplied by distance, or force multiplied by distance. So we've got this force, 800, and what is our maximum distance? Our maximum distance will be 1, because this span is 1 meter, so our maximum distance will be 1, right? And so this will give us 800 Newton meters as our maximum moment. But what we're looking for is not the moment, we're looking for the maximum load. And we know that this moment, this side, should be equal to the moment on the left for it to be able to balance. And so we have, so we'll call this M1. Let me write it here. So we'll say M1 is equal to M2. And we know that M1 is equal to 800. M2 is equal to force multiplied by distance. Right? We've got the distance, the maximum distance is 2. So we have 800 equals 2 multiplied by force. And we can find the force to be 800 divided by 2, which gives us 400. So taking the information given in the diagram, our maximum load would be 400 newtons, which is B, if we were to go by the information given in the diagram. But if we were to go by the information given in the question itself, and assuming this to be 200 newtons, then we'd have different figures, and would have 200 multiplied by 1, which will give us 200 Newton meter as our maximum moment on the right. And the maximum load that we can carry on the left would then be 200 is equal to the force multiplied by the distance, which is equal to, so 200 equals, our force is what we're looking for, and the distance is 2, and so we would have our force or our load being equal to 100 newtons, right? So going by that, we can assume that the correct information was the one given in the diagram, and so going by that, we would say our correct answer is B. But there was an error with the question phrasing and the correlation between the relation between the question phrasing and the question diagram. But I hope you understand how to tackle such a question. Question A7. A7 says, a dog running at constant speed of 3 meters per second increases its speed to 7 meters per second upon seeing a lion. If the mass of the dog is 20 kilograms, the work it does in achieving the new speed is, so a dog running at constant speed of 3 meters per second increases its speed to 7 meters per second. So we have its initial velocity, which is equal to 3 meters per second, and we have its final velocity, which is equal to 7 meters per second. Is 7. What else are we given? We're given the mass, its mass, which is equal to 20 kilograms, right? 20 kg. The work it does, if the mass of the dog is 20 kilograms, the work it does in achieving the new speed is, so how do we find work? So we know that work is equal to force times distance, right? But do we have any distance? No, we do not. So how do we tackle this question then? We know that work is simply equal to energy, right? And we know that energy is given by, for example, potential energy is given by mass times gravity times height. We have the mass, we know the gravity. Do we know the height? No, we do not. Which other equation do we know for energy? We know that energy is equal to mass multiplied by velocity squared, right? And this is kinetic energy. So kinetic energy is moving, is energy in motion, and this dog is in motion. So we definitely have to go with the kinetic energy equation. We've got the mass, we've got the velocity, but we've got two velocities. So how do we tackle that? We say energy equals to mass multiplied by the velocity, which is simply equal to the final velocity minus the initial velocity squared, right? This gives us 20 multiplied by 7 minus 3 gives us 16. So 20 multiplied by 16. 20 multiplied by 16. So the other energy equation is energy equals half mass multiplied by velocity squared. So can we use this other equation? Well, definitely we can, because this equation is for kinetic energy, which is simply energy in motion. And so this dog is in motion because it's moving, it's running at this speed to that speed. But then how do we use this equation given two velocities? We have 3 meters per second and we also have 7 meters per second. So which velocity do we use? So here's what we do. So we've agreed to say we're going to say half mv squared, right? And we have two velocities, which is the initial and the final velocity. So we'll say half mass, which is 20, right? Velocity, which mass, which is 20. Then velocity, we're going to say 7, which is our final, squared minus, so we can put the square brackets there, 7 squared minus 3 squared. So this gives us half multiplied by 20 is simply 10, right? And 7 squared is 49 minus 3 squared is 9, right? This gives us 10 multiplied by 49 minus 9 is 40, right? And then this gives us 10 multiplied by 40 is 400. So we have 400 joules as the energy which the dog is using. So this, we know that work is simply equal to energy. So this is the amount of work done by the dog to achieve that speed. So therefore the correct answer is C. We can move on to A8. A8 says a thermos flask contains a vacuum. What is the purpose of this vacuum? A thermos flask contains a vacuum. What is the purpose of this vacuum? So prevents A, conduction and radiation, B, conduction and convection, C, radiation and convection, D, conduction, convection and radiation. So the vacuum in a thermos flask is there to prevent conduction and convection and not radiation. So the correct answer is B on question A8. Question A9 says molecules of a liquid evaporate from a container and the temperature of the liquid left in the container changes. From which part of the body of the liquid do the molecules escape, and what is the effect on the temperature of the liquid left in the container? Molecules of a liquid evaporate from a container. So you have a container which is filled with a certain liquid. So you have a liquid in a container, and then you're told to say molecules are escaping from this container and the temperature of the liquid in the container changes. Now we're asked to say from which part of the body of the liquid do the molecules escape, and what is the effect on the temperature of the liquid left in the container. So there is evaporation taking place here. So which molecules do you expect to evaporate? Do you expect the ones at the bottom? Do you expect the ones in the middle there? Or do you expect the ones on the surface? Or do you expect the molecules in the whole, in all parts of the container or in all parts of the liquid to evaporate? Well, definitely the ones that will evaporate are the ones on the surface. So the ones on the surface are the ones that are going to start evaporating and moving from there. So do not expect the molecules at the bottom to evaporate and leaving the ones on top. So the ones on the surface are going to evaporate first, and they'll keep on evaporating and moving until the liquid is all done. So the molecules on the surface will evaporate first. So therefore, this is ruling out these two answers. So meaning these two are out. These two answers are out. And then we're left with these two answers, these two options. So because of the evaporation, what do you expect the temperature of the liquid to do? What effect will it have on the temperature of the liquid? Will the temperature increase or decrease? Well, if there's evaporation taking place, the molecules are leaving. What will happen is that the temperature of the liquid left in the container will decrease. And so therefore the correct answer is C. We can move on to question 810. 810 says the diagram below represents a transverse wave. So we've got points A, B, C, D, E, F, G, between which two marked points in the distance is the distance equal to the wavelength of a wave. So when you talk of wavelength, you're simply talking of the distance it takes for a full cycle. So you've got a wave like that. It is the distance that it takes from here to this point for it to make a full cycle, right? So to do that, if you are to cut this there and place it on top there, you're going to have a full cycle like that, right? So in this case, we're talking of point A to that point 8, but 8 is not labeled. They're asking us about which labeled points it would take for it to be considered a full wave, or for it to be considered as the wavelength of the wave. So would we say A to D? No, that's half a wave. Would we say E to F? That's still not a full wave. Would we say B to C? Definitely not. Would we say B to G? Well, if we say B to G and we place C there and B there, we would have a full wave. So therefore, the marked points that would be equal to the wavelength would be from point B to point G. Let's just check our answers and our options if we have B to G, and we do have B and G as option C. So therefore the correct answer is C. Okay, move on to A11. A light candle is placed in front of a loudspeaker that produces a loud, steady sound at regular intervals. So we've got a loudspeaker, we've got a candle flame. What type of wave is produced by the speaker, and in which direction does it cause the flame to tilt? What type of wave is produced by the speaker, and in which direction does it cause the wave to tilt, the flame to tilt? So firstly, we need to understand that when we're talking of a speaker, what comes out of a speaker? Well, it is sound. So a speaker will produce sound. And what type of wave is sound? Is a sound wave. So we know that sound is a wave. But what type of wave is sound? Sound is longitudinal. Sound is not transverse. And if we are saying sound is longitudinal, it simply means we have two options. We've got option A and option B. Option A and option D rather. And so option B and option C have been ruled out. And when we talk of sound waves, they're longitudinal, so meaning they can be either in this direction or in this direction. But where is the speaker facing? In which direction is the speaker facing? Is it horizontally? Is it vertically? Well, it's horizontal, and hence the sound wave will move in a horizontal manner, right? Causing the flame to tilt horizontally. So therefore, the correct answer is D, longitudinal and horizontal direction. Question 8.12. The diagram below shows three layers, so shows three rays of light incident on the boundary between a glass block and air. The angles of incidence are different. So we've got that, we've got that, we've got that. So we've got 20, we've got 40 degrees, and we've got 50 degrees. The diagram below shows three rays of light incident on the boundary between a glass block and air. The angles of incidence are different. What is a possible critical angle? So when we've got such a diagram or such such diagram or such experiment, when you talk of the critical angle, we're simply talking of the angle at which so we've got two mediums, we've got air and glass. So the angle at which, let me just change the color. So we're talking of the angle at which this ray will hit this medium and continue in that direction, the direction of the medium. So we are simply talking of this angle here. This is our critical angle. So we can call it critical angle. That is our critical angle. So now how, according to the diagrams or to the options, to the diagrams we've been given, do we have any ray that is hitting the other medium at that point and continuing in that direction? Well, this one goes through and continues at a refracted angle. This one also goes through. This one just bounces, but none of them is going in that direction. But we know that this goes, turns like that. This one turns but tilts a bit towards the boundary between the two mediums. This one just bounces. So if, actually, supposed to do that. So this angle is a critical angle. This angle here is a critical angle. So now the question is, what is a critical angle? So what is a possible critical angle? We cannot find the exact critical angle, but we can find an estimate of the critical angle. So this one goes through, but is a bit more steep. This one is less steep. This one just bounces off. And we know that what we're looking for is this angle that causes it to turn and be in the same direction or in the same line as the boundary. So if we look at the angles we've been given, 20 makes it turn really steep towards that line there. 40 makes it bend a bit towards the boundary, and that's what we're looking for. 50 is just down the boundary. So for the angle to make it be in a straight line as the boundary, we know that it should be greater than 40 but less than 50, right? Because the less than 40 is too high, more than 40 or more than 50 is too low, so it should be between 50 and 40. And let's look at the options we've been given. We've been given 60, 45, 30, 15. So the correct answer would be 45, which is between 50 and 40. 60 would make it tilt more downwards. 30 will make it tilt a bit more upwards. 15 would definitely make it tilt even more upwards. So the correct answer is 45. A13 says, the diagram below shows an object placed underwater and being viewed from the top. So we've got an eye, we've got water, we've got 14 centimeters, and we've got 3.3 centimeters. what is the refractive index of water? So grade 12s, even as you prepare for examination, this is something that you should just know, to say the refractive index of water is equal to 1.333. And looking at the answers we've been given, the correct answer would be A, 1.31. Question 14 says, the diagram below shows a steel magnet being withdrawn from a coil of wire in the direction shown to a point as far away as possible. What is the effect on the steel magnet due to this action? So you've got a current passing through this wire. You've got a steel magnet that is being moved out. So when you have a steel magnet and you've got a current, what happens is that the magnet gets demagnetized. So if you have an AC current, or rather you have an alternating current, and you have a magnet, and you have a coil, and the magnet is moved out of the AC, what will happen to the magnet is that it will become demagnetized, and that is option C. We can move on to question A15. The diagram below shows an illustration of a transformer with 100 turns on the primary coil, so 100 turns on the primary coil, and 25 turns on the secondary coil, 25 on the secondary coil. So what type of transformer is this? This is a step-down transformer. So you've got 100 to 25. So the number has decreased from the primary to the secondary. You've got 100 to 25, which is a decrease in the number of turns. The question then further goes on to say, what is the voltage induced across the secondary coil? What is the voltage induced across the secondary coil? So we've got 12 volts on the primary, and what is the voltage on the secondary? So this is a step-down transformer. So if you've got 12, it means that it will be stepped down to something. So now we need to find the step-down factor. So to do that, we're going to say 100 divided by 25. So we've got primary divided by the secondary. So 100 divided by 25 gives us 4. So 25 into 100 gives us 4. So meaning this is being stepped down 4 times, right? So to find the voltage in the secondary, we'll say 12 divided by 4. It is being stepped down 4 times, which gives us 3.0 volts, which is option A. We can move on to question A16. A16 says, the diagram below shows a positively charged rod placed close to 2 metallic spheres, A and B, which are initially neutral. So we've got a charged rod which is positive, and we've got A and B, which are initially neutral, but then looking at them, we've got negative and we've got positive on this side. So which statement is correct? So what has happened is that there is a positive charge on this side, a great positive charge, which is, and you know that opposites attract, so positive will attract the negative, and then there's B. So initially these rods were like this, so we've got A, these spheres were like this, we've got A which has positive and negative, and B as well, which has positive and negative. And then we've got a rod which is positive being introduced near A. So what will happen is that, as I said, opposites attract, and therefore the negatives will be attracted to the rod. So the negatives in here will move so these two are in contact actually, there's no space in between them. So the negatives that are in B will move to A, and then positives in A will move to B, and so we'll have a lot of negatives in sphere A and a lot of positives in sphere B. So which statement is correct? Is it A, lost positive charges to sphere B? B, gained electrons from sphere B. C, has gained electrons from charged rod. D, has lost positive charges to the charged rod. So what has happened is that the negative electrons have been gained by A from sphere B. So therefore the correct answer is B, gained electrons from sphere B because of this great attraction, this great force of attraction that has been presented by the positively charged rod. Question A17 says, the diagram below shows a circuit with 4 ammeters connected at different positions and 3 resistors of different values. Which of the 4 ammeters labeled A, B, C, or D would show the largest reading? So we're talking of ammeter, and ammeters, what value or what does an ammeter measure, or what does an ammeter read? So ammeters read current, right? And what instruments are used to read voltage? Voltage, we use voltmeters. So don't forget, voltmeters for voltage, ammeters for current. So current, we use ammeters. And what is the formula for voltage? So which labeled A, B, C, or D would show the largest reading? So is it A, which is between 10 and the main circuit? Is it B, between 10 and 20? Is it C, that is between 20 and 10? And is it D, that is encompassing all resistors? So when you're dealing with ammeters, ammeters will give you the largest reading at a point where so let me say it like this rather. So what happens is that when you've got current going through a circuit will be the same at this point and at that point. So what will happen is that current will come, then some of it would take this route, some of it would take this route, and some of it would take this route. And the summation of all these currents should be equal to the summation, the current that is leaving the cells that you have. And then as they come back, they'll come and join back here. So this current from here will be there. This current from here will be here and join the current that is coming from here. And this current from here will also join these other currents, and these will sum up to the same current that started. So what you'll find is that the current here will be different from the current there, from the current there, and from the current there. And the greatest current that you can find will be the current that is at option D. Why? Because this is the summation of all currents in the circuit, or that are going through the parallel parts of the circuit. Okay? So this one will be less, this one will be less, this one will be less than these ones. But the summation of this current and the current there should be equal to that current. Okay? But this is simply a summation of this current and the current there. So it's not the greatest. So the largest current reading will be at point D. Then question A18 says, a secretary in a manager's office uses the following appliances with respective power ratings. So we've got an electric kettle with 1200 watts, a printer with 600 watts, a computer with 100 watts. Given that the cost of electricity is 0.8 kilowatt hour, calculate the cost of operating all 3 appliances at once for 12 hours. So firstly, let's find the total power that is being consumed by this secretary and these appliances rather. So we've got 1200 plus 600 plus 100. And this gives us 12 plus 6, 18 plus 1 gives us 1900. And what are the units? Watts. And this in kilowatts will give you 1.9 kilowatts. Right? And we've been given that the cost is 0.8 per kilowatt hour. And how many hours were these appliances used for? 12. So we're going to multiply 1.9 by 12. And then after doing that, we are going to multiply this 1.9 by 12 by 0.8 kilowatt hour, right? And then when we calculate this, when we do our calculations, we use our calculator, we'll find that this will give us 18.24. And we have 18.24 on any of our options, and 18.24 is option D. So therefore, the cost of operating all these appliances for 8 hours is 18.24 kwacha. Question A19 says, which of the following is correct about the purpose of X plates and Y plates in a cathode ray oscilloscope? So X plates are like that and Y plates are like that. So these two types of plates are used to deflect the electron beam. They are both used to deflect the electron beam, and the horizontal ones are used to deflect in the Y, the vertical ones are used to deflect in the X. So these two plates are used to deflect the electron beam vertically and horizontally so that it can move in a certain fashion, in a certain way, which is usually in a straight line. So we've got the X plates deflecting it horizontally, we've got the Y plates deflecting it vertically. And so the correct answer is C, which is deflecting the electron beam vertically and horizontally. And the last question that we're doing today is, or that we're doing in this video, is A20, which says the diagram below shows a box for storing radioactive sources. Which material is best for lining the box to prevent the escape of most radioactive emissions? We've got lead, we've got steel, we've got copper, we've got aluminium. So which material is best used to restrict radioactive materials from escaping? Is it lead? Is it steel? Is it copper? Is it aluminium? The correct answer is lead, which is A. So lead is highly impermeable by the radioactive materials, and so it is used for lining of the box. So the correct answer is A. So this is where we'll end in this video, and in the next video we'll move on to section B of the same paper, and we'll move on to section C in different videos that will come. So thank you very much for your time, and remember to like the video, remember to subscribe, and remember to tell your friends about this video and many others that we are offering. So thank you very much, and God bless you.